Okay, guys. So this is the last part of space trust. Last part of subject for statically determinate trusses. So the last part is space trusses. What is space trusses? A space truss consists of members joined together at their ends to form a stable three-dimensional structure. So it's a three-dimensional structure. It's shown in this figure. It's a three-dimensional. You can see this is the axis about that. So the simplest form of a stable two-dimensional truss consists of members arranged in the form of triangles. So you can see this one triangle, two triangles, and three triangles. So as it is in the three planes, so the determinacy and stability is also different. In three dimensions, there are three equations of equilibrium available for each joint. So the first one, there are three equations. There are three equations of equilibriums for each joint. So due to that, so the equation is slightly different, which if they multiply it became three instead of two. So there are three classification. So the first one is when your B plus R uh, is less than three times join. So it became unstable trust because the number of bars or number of support is less than the number of joins. And then the second one is statically determinate. We need to check for stability. This is when your B plus R is equal to 3J. And then the last one is statically indeterminate when your B plus R is more than 3 plus J. And also you need to check for stability. So assumptions for design. The first one in table 3-1, the Hibbeler book, structural analysis. So the first one is short link. Where short link we assume that uh, the support here is pin, but once in the member here they become just like a roller support with one reaction only, FY. So if the support is roller at the end, so still similar, but you have uh, only one reaction on the vertical axis. In this case, in three dimensional, it will be the z axis. So if the support is slotted roller constraint in the cylinder, so you have your member here being slotted into a cylinder here. So the the reaction, it can still move on the y-axis, but the movement is restricted on z and x-axis as shown here. So you have a reaction here. This you have a reaction of fx here and fz here, but there's no restriction on y-axis due to your roller can move within the cylinder. And the last one is ball and socket. So you have a ball and socket here. So basically you don't have any moment here. It is the support. So there's no moment. You only have three reaction that constrain the movement, restrict the movement of the member or the stresses overall in three directions, fx, fy, and fz. So that is all for trusses. So I have a maybe we can take a look at some of the space trusses in the actual construction. So here's the number one. Maybe we can put out images. You can see this is space trusses. Um, Very like rectangular space trusses, but still a space trusses. Maybe a combination of space trusses and simple trusses. This is one that we use often see in stadium example. So this is type of space trusses, as you can see here, the truss here, supporting in three-dimensional, supporting this dome. This is inverted. This one very interesting space trusses, giving the shape to the building. Maybe just for aesthetic um, purposes. This one is also for roof, giving you that very interesting shape of ceiling there. Let's see, last one maybe we should see at stadium, space classes at stadium. So this one you can get a cantilever um, roof due to that space trusses, so you reduce the self weight of the structure, but you gain that and then you still get the overreach, the overhang of the structure. So this one is the enclosed one. You can see the space structure is below that is holding up this roof heading. So this is very common. Even in Unimap, we have this steel space trusses supporting the the roof. It's also in stadium. Maybe some of you, the fan of football, very familiar with this type of trusses, space trusses. So that is all. I hope this pique your interest and hope that you have your own self-study and prepare for your exam, because this would definitely be in your exam analysis of trusses. That will be all. Thank you. Thank you for your attention.